Good morning, everyone, and welcome to the first Recolight webinar of the year. Today, we're looking at environmental product declarations, a user's guide. And we have three stellar speakers as usual. We have Kael Gillam, who's a senior associate at Hoare, the built environment consultancy. We have Teresa Kleber, who is the portfolio program manager at Ledvance. And we have Max Robson, who's the environmental metrics manager here at Recolight. And I am going to be your chairman for the next hour and a half or so. Just a bit of housekeeping before we kick off. We will be recording today and it will be available afterwards. We will post this to recolight.co.uk webinars in due course. The slides, if you register today and join, you will get the slides later by MailChimp, so keep an eye out for those. You should get it within the next 24 hours. Check your spam folders if you haven't received it. Just to say, there's two boxes you can interact with us today. You have a chat box and you have a Q&A box. So if you could put questions or comments, and we really welcome them, by the way, into the Q&A box. That's the one that myself and the panelists will be monitoring it. But use the chat box if you've got any technical issues or anything about the webinar and about admin stuff. And my colleague Suzanne will be monitoring that and will be able to answer any questions you may have. So the running order is as follows. Max is going to kick us off with an overview about EPD documents. So expect cheerful facts about the functional unit and all that type of thing. Next, Teresa will give us a manufacturer's perspective on how they manage data and EPDs and the challenges and opportunities around them. And finally, we'll get a designer's view from Kael Gillam and how she implements the data into her workflow. And she's going to look at a real world case study, which will sort of bring it home. And finally, when we get to the discussion afterwards, Nigel Harvey, CEO, is going to join us and join the panel discussion. And we aim to finish today at around 12:30. As I said, this is the first of a number of webinars, and we have three later scheduled for this year. On Thursday, the 19th of March, 11 o'clock, we are drilling into Cat A lighting, the alternatives, how we can reduce waste. We all know there's not a silver bullet in this world, but there are a number of alternative ways that we can cut down on the waste from Cat A fit outs and stop your ceilings and luminaires and raised ceiling access floors ending up in skips. On Thursday, 23rd of April, we're having a deep dive into EU environmental law. And we look at the implications for the lighting sector, specifically manufacturers. And this is a fast changing world. There's a lot of green legislation in the pipeline. So this will give you a good chance to get on top of that. And in September, on Thursday, 17th of September, for the first time, we're going to drill into DC lighting and look at, what are the opportunities with DC lighting to take an extra step in sustainability and energy reduction. And we have some very interesting speakers on that, and we'll be looking at what's happening in Germany, where a lot of manufacturers are using DC lighting ecosystems in their facilities. There will be more announced, so please keep an eye on the space and on our webinars. A shout out to the Circular Lighting Report. I'm the editor. This is a weekly update of all the news in sustainable lighting. We have videos, interviews, we have stories about what projects and products and techniques, and you can follow us either on the website at recolight.co.uk/news, or you can also follow us on LinkedIn. So just search Circular Lighting Report and follow. You can also send me any news projects to my email address, ray.maloney@recolight.co.uk. Another date for your diary, the Circular Lighting Live, which is our flagship event, is slightly later this year. It's going to be on the Thursday, the 8th of October, 2026. We're again at the Minster Building in London, and we have two tracks, lots of talks, panels, micro talks. We have a full exhibition alongside where you can see the latest sustainable luminaires. There's also the Build Back Better Awards, a presentation ceremony, and yeah, so we definitely recommend you get that on in your diary. Just an update on some relevant life cycle assessment services that we at Recolight produce. There's training workshops. We can do bespoke training workshops for manufacturers for practices. Look at LCA methodology, EPD standards, programs, verification, and all that type of thing. And we also offer a one-off environmental product declaration service. So you could do this for some of your hero products. It's just a one-off. It gets you started. It gets you started on your EPD journey. So just get in touch, and we can talk you through how those services work. Before we kick off, I just wanted to get on your radar a couple of projects which we've covered recently in the circular lighting report. This is Endenica, 100 Fetter Lane in the City of London. It's a 14-story building by Fletcher Priest, the architects. It's an all-electric building. It uses 30% less energy than a standard building. It's got a roof terrace, it's got a pocket park, and it's got all the things you would expect of a post-pandemic building. But what's really interesting is that this is the first UK building in which every component has a material passport. And not just any passport, a centralized and standard one developed by the Waterman Group. Now, the benefit is that it makes it much easier for all the elements in the building to be maintained and also, and crucially, to be deconstructed, reused, and recycled at end of life. The lighting was supplied by H Lighting, and they supply Hala lighting from the Czech Republic. And they supplied 1.2 kilometers of linear direct indirect. And they obviously built on information from their EPDs, and they added more details about the driver components, which information they got from Tridonic, and also information about how the luminaires can be deconstructed. So they used in this building is the Lena 80 direct indirect pendant. So they got an EPD, but they also added lots of more information about how the products can be removed and disassembled and reused, etc. And the benefit is that, you know, even the tenants get visibility on those products and how they get used, and they can drill into all the components of the space. This is another project, well, it's two projects really. This is Rathbone Place, again in London, and here the fit out specialist Ambit is carefully stripping out this SAS ceiling and these lead look luminaires, and they're going to be reinstalled at another building, the Broadgate Tower, a British Land building here in London. So I think what's great about this project is it's demonstrating reuse in action, and it's all been coordinated by the fittings and interior sector. So I should give a shout out here to Hattie Emerson, who's the project manager on this project and in this coordinating it all. But it's a really interesting example of collaboration and reuse, and how even though these ceilings and luminaires have been in the building since 2012, but they still have a lot of life left in them, and it's great to see them getting reused in this other building. Finally, to mention that, you know, as part of the reuse project that FIS is conducting, they periodically offer luminaires and raft systems that are looking for a home, basically. So this week there's two projects in which they're looking to rehome products. This is the first one. This is an SAS 30 ceiling with 600 panels. It includes 100 Whitecroft City Line luminaires. The whole, if you buy that new, it will cost you £40,000. FIS is looking to rehome that. They're not free. There will be some consideration, but that's to discuss with them. This is the second project, and this is SAS 600, 80 infill tiles, 32 end tiles with 30 Fagerhult luminaires. And these are some of the luminaires that are available on the FIS Reuse Hub. And you can go on their website and just navigate, and you can see um, lights and ceilings that are coming out and how you can reuse them. So I recommend that to you. So that's it. I'm going to kick off now. I'm going to hand over to Max to get stuck into the webinar proper. And I'll just stop sharing. Max.
Perfect. Thank you, Ray. I'll start sharing my screen. I'm going to assume that you can see that okay, and rely on Ray to shout out if you can't.
That's fine. Yeah, that's good, Max.
Perfect. Thank you, Ray. Good morning, everyone. Thanks for joining us this morning. I'm very excited by today's webinar, not least to hear about what Teresa and Kael have got to say. But I'm going to give a bit more of an introduction, provide some context, and I guess highlight some of the aspects of EPDs that I think are important for an EPD user to appreciate. So hello, my name is Max Robson. I'm the Environmental Metrics Manager at Recolight, and I run the LCA services that Ray just previously mentioned. There we go. Just to give you a flavour of what I'm going to be talking about, I'm going to give a bit of an understanding of what embodied carbon is. I want to impress upon you the process involved in creating an EPD, so how EPDs are created. How to find an EPD, because once it has been created, it is readily available for anyone to access. And then I'll go a little bit into EPD interpretation and use. But to start off with, I just want to kind of show this graph, and I've spoken to this graph before, but I think it's really good at providing providing context. So this is a graph of EPD data from I think over 100 EPDs that's been plotted, or efficacy against global warming potential. Kind of global warming potential is you can kind of call your carbon footprint. And I don't necessarily want anyone to look at the numbers themselves. I just want you to appreciate the trend here, and that is that you've got an inverse proportionality between your efficacy on the bottom and your global warming potential. What that means is, as we see an increase or improvement in efficacy as technology improves, we're always going to see kind of a residual global warming potential because it's kind of asymptotic. And that residual global warming potential, therefore, isn't necessarily completely to do with the use phase, but it's actually to do with the materials and the processes that are then embodied within the production of the products themselves. So it's this interplay between the use phase and kind of all the materials that you're using. Another way to look at this is to consider the product's life cycle. Obviously, we're talking about luminaires here. So material extraction, transport to manufacture, manufacturing itself, the use phase, removal, and end of life. It's that use phase, as I say, that's your what's called your operational carbon. So it's the energy associated with that use. Whereas everything else, so your decisions, so your kind of material decisions, your manufacturing processes, the end of life treatment that is required, all of those impacts are associated with what's called embodied impacts, or in this case, embodied carbon. So we've got embodied carbon and operational carbon that are both very, very important metrics to consider when we're trying to understand and realize more sustainable lighting solutions. And what's really nice about these two metrics is that they're both calculated and declared within an EPD. But what is an EPD? So I'm going to assume that there's a basic understanding of what EPDs are, but I'm going to go over it briefly here. So an EPD, or an Environmental Product Declaration, is an independently verified and registered document. It provides transparent information on the environmental impacts across a product's life cycle. So in order to do that, you have to consider all of the kind of what are called inputs and outputs at each of the different life cycle stages of a product. So that's going to be things like your materials, your utilities, your wastes, etc. All of those inputs are put through a model or calculation from which you get a set of results that are your set of emissions associated with that product. And those emission results are then summarized or kind of distilled into your environmental product declaration document. So the EPD is just a document, and it's just the vehicle by which you can communicate those metrics. Now, what I've shown here is kind of a high-level overview of how an EPD is created, but it's actually far more comprehensive than that. There are multiple stakeholders involved, so I'm going to kind of walk through it this morning. So to start off with, you're a manufacturer that wants to create an EPD. That manufacturer will commission what's called an LCA practitioner, a lifecycle assessment practitioner. The lifecycle assessment practitioner will say to the manufacturer, this is the information that I'm going to require. This is the input data and the output data that I need. And that manufacturer will feed that data back to the practitioner. That practitioner will then do the calculations, do the modeling that I mentioned on the previous slide, and they will do it in accordance with a set of product category rules. And product category rules are kind of another set of standards that they have to comply with to create the EPD document so that it is classified as an EPD. Those product category rules will be defined by what's called a program operator. Now, an EPD program operator is the organization that manages, publishes, and gets verification for the EPD itself. And so they're the ones that supply the product category rules. When the LCA practitioner has created the lifecycle analysis and the EPD document, they'll notify the EPD program, who will then assign a verifier. And this is so that you can seek third-party verification. The verifier will then feed back to the LCA practitioner and the manufacturer, probably asking questions like, where did you get this assumption from? How have you modeled this? Why have you done this like this, etc., etc. Once the verifier is happy, they will tell the program operator that they're happy to approve it, and the program operator will then publish the EPD on their website, typically on their website. I don't necessarily want people to get bogged down in the details of this. I just want to highlight that it can be quite a complex process. It's a process that can be simplified by certain service providers, but ultimately, I think anyone that's asking for an EPD needs to appreciate that this is a process that has to be undertaken, and therefore it can't be done overnight, which can sometimes be asked of manufacturers. So ultimately, the EPD is published on the EPD program operator's website, and I've listed just a couple of EPDs program operators here, and I've actually taken it a step further because you're going to get these slides anyway, and I've given you guys a kind of references or websites that you can go to each of these EPD program operators and find their databases or their libraries. Once an EPD is published, it has to be published on these libraries. And they're freely accessible. You might have to create a sign-in, but otherwise it's completely free. And some of them are just so readily available you can do it without even signing in. I should note here that these are examples. There are plenty more program operators out there. Some are more reputable than others. What I would say here is that if you're looking at an EPD and you want to understand whether it's a reputable program operator, a really good place to have a look is Ecoplatform. Now, Ecoplatform is an organization that they're an umbrella organization that sit above various program operators within the construction space. In order to be Ecoplatform associated, the program operator has to be audited by Ecoplatform, and it's a really good mark of reputability. One of the easiest ways to tell whether an EPD is Ecoplatform verified is that it'll actually have a little stamp, usually on the first page of the EPD, that says it's Ecoplatform verified. A really good mark of trust. So that's how to create an EPD. I also want to talk a little about the data that goes into the EPD and the data that comes out of it. So the data that goes into an EPD. Now, if we come back to this product life cycle, as I've said, the input data is going to be all the different inputs and outputs through the different stages of the product life cycle. So it's going to be your materials, it's going to be your utilities, it's going to be your wastes, and those are different inputs that happen at different sections of the product life cycle. Now, there are actually two different types of data that we're talking about when we consider the product's life cycle. if we take the material extraction, transport to manufacturing facility, and manufacture, the data associated with these sections of the product lifecycle are actually real data. You know what your procurement is, you know what your utilities are, you know what your wastes are, or a manufacturer knows that information. And so that real data can then be used within the EPD. When we get to the stage, the point at which the product is handed over to the customer, things change because you've no idea what the customer is actually going to be doing with that product. And so we have to model what is kind of like an intended life cycle of that product. And so pretty much everything from there on is scenario based. And so it's using data that's based on averages and assumptions. And I just think this is an important thing to appreciate because as an EPD user, in whatever capacity that is, you have to appreciate that two EPDs that are for very similar products may well have quite different assumptions embedded in their calculations for the latter stage of their life cycle. And those are assumptions that are good to appreciate if you are looking at EPDs. So that's just a note on the information that goes in. I think it's also worth talking about the information that comes out. And so that's the information that's put into the EPD. So the core of an EPD comes down to kind of these environmental impact data tables. And they'll all be relatively standardized and look something like this, which is somewhat unfortunate because they can look quite imposing. And so I've spoken about this before, but I speak about it again and try and do a little bit of an interpretation of a table like this. So this is environmental impact data, and it's the core environmental impact indicators. And you can see across the top, you've got these codes A1, A2, A3, A4, all the way through to C and D. Now, these are standardized notation for the different life cycle stages of a product or a building product or a building. So if I label these, it gives a lot more clarity. You've got A1 material extraction, A2 transport, A3 manufacture, and it goes all the way along. You've got your end of life processes as well and your use phases in the middle. So that's what those codes mean. And then down the left-hand side, we've got environmental impact categories. So it's not just about carbon, but it always takes the limelight. You've got global warming potential, kind of your carbon footprint. That's broken down into different sections. But then you've got other impact categories. You've got ozone depletion potential. You've got acidification potential, smog, water use. All these different impact categories that have to be declared within an EPD, and that's kind of what gives this table such a comprehensive overview. But what this means is you can take a specific impact category and you can take a specific life cycle stage and you can read off the data from there accordingly. And so we can do this and we can relate it back to what I was talking about at the beginning of my talk, where we're comparing the operational carbon versus the embodied carbon. So operational in orange and embodied in blue. And if we take the global warming potential total, and I've just highlighted here the different sections that refer to the different elements of the life cycle. So you've got your operational energy, your B6 stage, which is the use phase, and that's typically kind of a real hotspot. And then more or less everything else is then your embodied carbon. And so you can see how we've gone from quite a comprehensive table, but we've broken it down a little bit to relate it to, particularly to carbon in this case, but you can relate it to other impact categories too. Another thing I just want to note here in green is the A1, A2, and A3 material extraction, transport to manufacturing facility, and manufacture. These are the life cycle stages over which a manufacturer arguably has the most control. And so it's more than likely that an EPD user, someone that's actually looking into the numbers in an EPD, is probably going to be concentrating quite a lot on that A1 to A3 phase. And that A1 to A3 is also called cradle to gate. And I just thought it was worth highlighting. So that's kind of an interpretation of the results table. I've said that EPDs are standardized, but unfortunately they don't all look the same. The information is always there. It's just, it could look more like this. It could look more like this. That's an unfortunate nature of the EPD world, but the information is in there as, according to the standard, it has to be reported, and all of these different impact categories have to be reported. So I just want to finish off, excuse me, I just want to finish off by highlighting another really important aspect of EPDs from a user's perspective, and that is the difference between a declared unit and a functional unit. Now, Declared unit and functional unit, you can think of more simply as a declared unit is concerning the environmental impact associated with a product, whereas a functional unit is the environmental impacts associated with using that product to light a space. And obviously, that product is going to have a certain spec and a certain function that it can fulfill, but it may well be that you need more than one of that product or less than one of that product to fulfill that function. So the declared unit is the product itself, so you can report EPD data on the basis of it on the declared unit level. So your results are saying this is the environmental cost if you produce one of these products. Whereas it's quite standard in the lighting industry to use a functional unit of providing 1,000 lumens of light for 35,000 hours. Now, based on the spec of this made-up luminaire that I've created, in order to fulfill that function, you actually need about 3 of this product. And therefore, if you're reporting environmental impact data on a functional unit basis, the numbers are going to be 3 times as large. So it's really important to understand that when you're looking at those numbers that I just spoke to, you understand whether it's the declared unit or the functional unit level. To kind of relate that back to what we were just looking at, this is data for a completely random product, not related to the example that I've given here. But you can see environmental impact data, and this is results on a declared unit basis, and this is on results on a functional unit basis. And EPD could report on either. And it's important to see that that A1 to A3 that I mentioned, in this case, is about 137, whereas this case it's 2, and this is for exactly the same product. And so it's really important as the EPD user to appreciate this difference, particularly when it comes down to potentially trying to make product comparisons, because you can't compare the declared unit for one product directly with the functional unit of another. I hope that makes sense. But that's kind of a broad brush list of things that I think are important to understand as an EPD user. I thank you for your time, and I will now pass over to Teresa from Ledvance. So I will stop sharing my screen, and Teresa can jump in.
Thank you very much, Max. One sec. Where is the sharing button again?
The green one down the bottom.
Ah.
Yes, we can see that. Yeah.
Thank you very much, Ray. So yeah, I'm actually quite excited also to get now the opportunity to share the Ledvance perspective about EPDs, and maybe also to guide you through some challenges and opportunities we had to face by integrating also EPDs into our day-to-day business and for lighting products. So I will first start with, next slide, yeah, the why. Why EPDs matter more than ever, maybe. There are several reasons behind, and that's also the first thing you, as also a lighting manufacturer or a company which wants to create an EPD, should be kind of clear about and define which purpose is behind. Is it mainly to calculate your own corporate carbon footprint and a product carbon footprint, fulfill customer requirements, as they are also sometimes mandatorily or not really have their own sustainability strategies, want to calculate their own corporate carbon footprints, other legislations, soon also to become and to be more detailed with the EPBD, Energy Performance of Building Directive. And of course, also the other side, country-specific requirements. That's not just, as Ledvance is not just operating in UK, of course, also almost globally, but my main focus is Europe, also for EPDs for now. Then also several countries have other requirements, and they have their some public procurement policies. Is it part of a tender? Do you want to use an EPD or within green building schemes, or to get a certain, I don't know, grade within it? So that's the first thing which should be clear. Why? which then is impacting also maybe the program operator. So thanks also to Max, he's shown 3 or more different program operators like EPD International, PP Eco Passport, EPD Hub. And also that would again also lead to defining which software. So some software solutions operate with some program operators and so on. So that's the first thing that company or lighting manufacturer should clarify. And it can also be quite challenging to find the right way to fulfill country-specific requirements. The next, after this is clarified, we started, or speaking of Ledvance, with some pilot EPDs. Thanks to Max, he's also described the process itself. I've kind of made it here a bit in an easy structure, like a waterfall. First, we start with, after defined, of course, the program operator, selected some rules. And the software solution, we start with the data collection, or started with the data collection, then run and model the ACA, generate the EPD itself, and then went through all the verification and publication processes. And of course, that's not a one-by-one process, it's more an iterative process at all. And yeah, the question to you somehow is a bit, or to think about what you guess how long our first EPDs, the pilots, took us. So as you can see, maybe, or an imagination already, that EPDs are not just certificates, there's a lot of work behind. So it took us around about 9 months for our first EPDs. Within that process, of course, it's also for us, we learned quite a lot through the data collection, what are challenges, then the whole modeling itself, also quite challenging if you do it for the first time. That's why also, for example, Recolight is a perfect partner also to support with the whole modeling. Then went through verification, and of course, as EPDs is a growing demand, not just in the lighting industry. There are limited number of verifiers available on the market. So this will be, or is already, a bottleneck. And then also the availability of processable data, not just the input data, but also output data, the results of the global warming potential and other environmental impact indicators to be used in other processes behind. Which was quite interesting, that there were mainly last year several or a paper and guidance document from the German ZWEI that Ledvance is not the only one facing those issues, challenges with EPDs. So data availability and accessibility is the main part. Also the complexity of the data collection itself. You first have to also explain someone, what do you need, or if it's internal colleagues or also external suppliers, what do they have to share. Therefore also, in line with that, lack of experience, methodology knowledge. Then it comes to the next part. Okay, as soon as you have an EPD, how can you compare it? Lack of comparability due to inconsistent standards. That's quite nice, as also within Lighting Europe, we've defined this product-specific rules for luminaires, where also Ledvance is highly involved. Also thanks to my colleagues on that. Really that is one of most important topics, harmonization and standardization within the industry. So talking about challenges, but how to solve them somehow, I can just tell you, work on those topics to reach also, or to keep on stay on track. to reduce those challenges or face the challenges and find sometimes creative solutions or have a steep learning curve. So we had basically after our first pilot EPDs, great learning how to run LCAs and create a model to have a standardized process behind, automate maybe also some processes. Then once everybody's trained, it's much faster. So that's why we've had the opportunity to streamline also our process to reduce also somehow the lead time by 70% roundabout. Of course, there are several iterations behind. And then overall, our goal is also for the next upcoming months, I would say, to be even faster, especially also coming from an individual verification, maybe also to streamline that verification part with some program operators are offering that and to provide process or tool verification. So that's always a tricky part. There are always pros and cons with each program operator. Yeah, that's about mainly challenges and also how we overcome those challenges within the process to generate EPDs. But yeah, what do we do now with those EPDs? What are our opportunities and how they can be used? Mainly to first create transparency about environmental impacts of our products. Also to see, okay, at the end, probably most of you know already, okay, the use phase has the highest impact throughout the whole life cycle for especially in the lighting industry. But there are a lot of people, customers, also internal salespeople, they are not aware of that fact. So it's really important also to create transparency and visibility of a product's environmental impact. And also what's mainly this is part of our sustainability brochure. Also, the intention was to show that it's quite important to create even more highly efficient LED technology or to find other solutions to reduce the energy consumption during the use phase. For example, via light management system, daylight harvesting, and so on. So how to reduce at least the main portion of the global warming potential of products life cycle. So that's one part mainly, and the other part is what do or can Ledvance do, especially with the manufacturing, how we can influence that fact. So I brought another example here, which is also or can be discovered in our sustainability report from 2024. To make also product improvements visible, to use the data and LCA for more environmentally friendly products, and to also do data-driven product development, define data-driven sustainability strategies by using and comparing our own products. So mainly we are using always the same kind of model behind that we are also able to compare several generations of products. In the specific example, we've compared a generation 3 with a generation 4 of a product family, mainly using also aluminium in the housing. And we extracted, or to simplify also the results a bit, we've just discovered or displayed here the global warming potential result for the declared product. So one complete product, not I just didn't want to make it too complicated by adding also the functional unit here, but that's mainly only the declared product, excluding also the use phase, so that we really can have a look on what is the impact of the manufacturing stage on the global warming potential. And basically, what are the changes between the generation 3 and the generation 4 of this product? We've used 100% recycled aluminium in the housing, which wasn't done before. Then the product lifetime was also extended in general, which leads at the end also to even better results per functional unit, because if it's a longer lifetime, or also if this was what Max has shown, the lumen per watt efficacy gets better over time. This reduces at the end also the global warming potential. And the third part is material efficiency. So we also were able to reduce the product's total weight by approximately 100 gram in that case, which helps us at the end to reduce the overall global warming potential, not just in the manufacturing, but overall. But here, just displayed on the slide, is that we were able to reduce the manufacturing by over 50% by using mainly also recycled material. And this gives us the opportunity not just to compare products, but also to use this for our own sustainability strategy, how we can move on with creating more environmental friendly products by using recycled material and other indicators. Good. Then one of my last things, so I'm quite fast. Actually, then is the question: we prepare a lot of EPDs, but where can they be found? If you're now a lighting designer, you want to use our EPDs, the global warming potential, maybe also compare it. Where can they be found and used? So more and more also manufacturers publish the EPDs directly on their own web pages, as we are also doing. So if you're in our e-catalog on our web page, you always find the EPD there if there's one available. But of course, it's not yet really in a processable format. So it's a PDF file. If you want to get a more processable information, you can also go directly to the PEP EcoPassport web page, where it's a bit more easy to copy and paste the rare numbers per life cycle stage and environmental impact indicator. Or sooner or later, that's unfortunately currently not the case, that our PEP EcoPassport EPDs got the Eco Platform label. See how this develops further. So either PEP EcoPassport, and then one thing, turning or looking on the left side of the slide, there is a screenshot from BIM object, building information modeling software, where also Ledvance is publishing a lot of product specification, product information, mainly about families, available there to directly download or use in, I don't know, software to do BIM. And there's also information about EPDs available, not yet the rare numbers, but at least a link to also the PEP EcoPassport platform, which is quite helpful, or should be quite helpful. And I'm also always happy to receive feedback on where to find our EPDs or how to understand also certain results. And with that, I want to thank you for listening. Then hopefully you can take away that, standardization and harmonization is quite essential in general, and how to and then early integration also into R&D to ensure sustainable, or at least more environmentally friendly products. And with that, I would like to hand over to Kael. I'm really curious about her insights and what she is sharing.
Cool. Thank you, Teresa. I will try and share my screen. All right. Hopefully that looks like a presentation to, everyone.
Yeah, that's good.
Grand, thank you so much. Okay, cool. Hi, everyone. So I'm Kael. I'm a senior associate lighting designer at Hoare. I use she, they pronouns, and I'm going to talk to you a little bit about basically what to do once you have all this stuff, or if you don't. Basically, what designers can do once you've asked the questions and you have the data. Right, so I think Teresa and Max both went over this quite clearly. So how we get the EPD report, it's about component data, geographical data, lifecycle assumptions, and specific luminaire data go into the report. And I'd like to just remind everyone, it is just a single data point, right? So we have to think about repairability, CRI. Is it suitable for well criteria? Is it suitable for your sector? Is it suitable for, is the photometry work? EPDs are just a data point in a landscape of decision making, right? So just because something has a low carbon footprint doesn't mean it's the right product for the right space. It doesn't mean that a low carbon footprint is necessarily indicative of so much more going on with the product. Again, Max pointed out there are issues like soil eutrophication and ozone depletion that we don't really talk about when we talk about the impact of a luminaire. So again, there's so much more to think about than just the big number. And I've been saying this, I think, for the last 18 months, just saying, don't look at the number that's on the sheet. Look at how a manufacturer gets to that point, what they've been doing with the data once they receive it. And I think Teresa actually really keenly showed that in, okay, we have a Gen 3 version and then a Gen 4, and this is what we decided to do to lower that carbon impact. So just like for manufacturers, the EPDs are a point in a landscape. So they will continue to grow and to continue to learn and continue to update the numbers in much the same way that we need to consider EPDs as a discussion tool, but also as just one thing to consider in the long list of things that we look at when we do our designs. So this slide might look familiar for anyone that was at Light 25, but the designer workflow, I think, is probably where I'm finding many other designers are stuck at the moment. And I actually had a call yesterday about people just asking, oh, can I have an EPD? Designers asking manufacturers. And the manufacturers go, why? And much of the time, it sounds like designers go, oh, I don't know. I just got told I needed it. Or the answer is, oh, well, I just need to know about, the content of luminaire. It's like, well, you don't need an EPD for that. So I would like to kind of take everyone out of the default question of asking for an EPD. It would be understanding what your brief is on the project and why you're requesting that data. So this designer workflow is mostly what you're doing now, I hope. So it's getting direction from your client, designing, doing your concepts, doing your drawings, doing your calculations, then requesting product information, right? So again, the lifecycle analysis information is just one part of your spec request. It is just one part. You get the photometry, you get the efficacy, you get everything and put it all together and make sure that it works for your Part L calculations or for whatever else you're doing. And then you also request this. Right, and then you review all that product data. So again, everything that you have to comply with, whether LEED, WELL, BREEAM, et cetera, against your client brief, confirm it, and then go back, right? So it's very much a part, I think, of what most of our kind of our spatial coordination, our technical design looks like, but just with the addition of getting LCA information and making sure that it is suitable to your project. Right, and this doesn't have to be an EPD. I know that today we're focusing on EPDs, but getting information about the environmental impact of luminaires is going to be different depending on what manufacturer you're asked, where in the world you are. Like, some of these things are just more or less readily available, and I still have trouble here in the UK, which I will highlight later with a bit of humility. So let me go through step one. Right, so this is a project I'm working on right now. In the City of London. And the direction from the client was this: we want to decarbonize the building through EPC enhancement and building repositioning, which is a really fancy way of saying we are going to redo the end of trip facilities and the reception, and we are going to upgrade the Cat A leased office plates. So what that entails is we need to figure out what's in the building, right? The biggest thing is what is in there, what can we do to improve? How can we carry out these works? Can we upgrade without buying very much new? And what can we retain that still is within its lifespan? So then we got to question that brief, right? So how do we achieve an EPC-A rating? What methodology is being used to calculate this? What do we need to provide from a lighting perspective? And short answer is, for many of these fluorescent retrofits, it's just increasing the efficiency of the electrical systems, right? So going from a fluorescent to an LED chip, which is going to be more efficient, last longer, and basically leave the carcass of the luminaire in the ceiling, because that has an awful lot of embodied carbon in the steel. Right. So with the Greater London Authority trying to get our building stock to an EPC C minimum, this is a great time for us to go in and say, okay, great, we're going to focus on efficiency. But then how do we define decarbonization, right? Like, what are we benchmarking against? Is there a known carbon emission for the building? Is there a carbon budget set by discipline for areas of deep refurbishment or light touch? And this, we didn't really have a specific answer to in this brief. It was just, we need to decarbonize because we know we have to, because it forms part of kind of our EPCA rating for the other services. And really what this ended up being for lighting is that we ended up getting carbon assumptions for what the existing luminaires were, versus what they would be when they're remanufactured. I'll come on to that in a second. And then what was missing from that brief? So these are also things that we had to ask is, are we trying to achieve any sort of higher BREEAM score? Are the offices being marketed as compliant to BCO, well, neighbors, etc.? And the answer was no, which was actually quite surprising for us. We assumed that we would be attempting to get a higher BREEAM, because I think currently the building is at good, and could have possibly been set up for excellent or outstanding. So going through all of that, we've got to translate that brief into deliverables. So we want to decarbonize, we want to get an EPCA rating. Number one, feasibility study. We needed to go on site. We had to have a look at what was there to understand what the assets are. And this is quantity of the fittings, quality of the installation, and known faults. Just because something's in an as-built and it's still standing doesn't mean it's going to be any good. Also doesn't mean it's going to be able to be repaired. I think that people get a little bit misty-eyed when we talk about like the days of lamp changing, how every single luminaire once upon a time used to be very easy to repair. But frankly, we're still going into buildings where we have early LED technology that is impossible to repair or is actually more costly from a time or carbon perspective than it is from just buying new or recycling or replacing components. What we also wanted to know was the age of the installation and what end of life planning there was for that already. So going through the operations manuals and then getting user and facility feedback on the installation. Do the people that are in this space like what they have now? And the answer to that was very mixed, as you might imagine, because someone who sits in the reception all day versus someone that's in one of the leased offices facing north versus one of the leased offices facing south. We had a lot of things kind of to contest with to find what the optimal solution was. And then the rest of what we do, right? Drawings, specs, controls methodology. So everything that we would normally do in a stage 3 and a stage 4. And then this is kind of the little extra on top, right? And this, I think, is where people say, oh, I don't have the time to do this. I think it's integral for this specific project that we're talking about energy efficiency and decarbonization, that we did get lighting calculations to determine power density, to compare them against the meter readings of the existing, and also to get the life cycle analysis calculations to determine the existing kilogram CO2 for the fittings against what we're proposing with the remanufacture. And these are some of the absolutely beautiful luminaires that we have on site. We have, just some linear battens in the cycle store. We have some, I think, about yay big diffuse downlights in the toilets. And we have these absolutely stunning fluorescent Cat A floor lights, or Cat A lights across the floor plate. And so we took a bunch of pictures. Our colleagues, so we're a multidisciplinary firm, so our colleagues went and did a Matterport scan of everything on site. So we kind of check our quantities against the base build information, against our photos and tallying, and then their Matterport, which was super helpful. And so then from what we saw on site, we kind of just put the jigsaw together, right? So what on earth are we going to be doing with these like 65 watt, ridiculously overblown, way too bright luminaires in the cycle store? That isn't just putting them in the back of house space. Can we repaint them? Can we relamp them? Can we do something to make these these three are the highest quantity fittings in the space? And they were the ones that we were focusing on. So what can we do to make these, and particularly the downlights, which are very much not au fait, make them part of the scheme? So we designed as usual, right? And we made some assumptions. We were very lucky in this case that this building had a lot of really good operations manual information and as-built drawings. And lucky for us, shout out to Simtronic, they still have this building kind of live for us to look at to see faults. So we knew exactly what the lifespan was of all the luminaires on the floors, and we also knew where there were faults, and we knew kind of that the office plate was functioning, which is great. But the luminaires that were designed, the manufacturer doesn't exist anymore. So that was, okay, how do we figure out what this luminaire is, what it's made of, and what are we going to do with it? And we were very lucky that we got a third-party manufacturer to come in and have a look at them, take one down, and make an estimate for what the carbon impact of that luminaire is, both in embodied carbon and operational carbon. And as you can expect, in a fluorescent fitting, it doesn't have a very long lifespan. The lamps don't, at least. But that steel in the casing, the aluminium in the casing for the luminaire, was a significant tonnage of kilogram CO2. And we went, okay, great. We can save the carcasses of these fittings, and they all have integrated sensors and what have they got? Sprinklers, sensors, and and smoke heads. So it was really like an integrated system that we were coming into, and how can we update this design with the smallest impact, right? So carbon impact isn't just about the fitting, it's about the system. We wanted to save the control system, and we wanted just to upgrade it from fluorescent to LED dolly. We wanted to keep all of the SAS ceiling tiles because they're perfectly good. This is an FM team that has actually cleaned everything, and everything's in good nick. And so the impact of just having the luminaires, kind of the kit replaced, is so much lower impact than having them replaced in situ. Let me just be clear on that. Is so much less of a carbon impact than taking it down, shipping it somewhere else, and again, and then back to site. So really, we're designing as usual, but just with a robust set of information about what the existing fittings are. And we made some assumptions about the photometry, and surprise, surprise, it works. It's great. And so then we acquired even more detail, right? So DRK were really kind. Shout out to them for doing all this work in looking at this luminaire and actually coming up with a cost savings, right? So what is your cost and carbon savings for changing all these luminaires out? And this was early. This is before we knew exactly how many fittings were going to be looked at. And it's massive. I mean, that's 3 tons of CO2 saved per year. Don't on this too much because we have updated this, but this is kind of a unique selling point for us as the lighting designers on this project, with a client that didn't really understand, what value we were going to bring in above what our electrical colleagues were doing. And so we were really quite proud to say, yes, like, we know manufacturers that can supply this data, that can give you kind of an idea of your new energy consumption, and that adds into the decarbonization and the EPCA. So really, we were trying to find as much of a robust set of data to say, this is what you're actually going to get once we're done with this design. And having that operational carbon, delightful. Not sending tons of perfectly good aluminum steel to the skip, delightful. But then we tried to get the new luminaires, the information for the new luminaires, and these are the responses I got. And like, bless these manufacturers. So they're smaller manufacturers. And obviously you cannot ask a very small outfit that is just starting on their sustainability journey to do you custom EPDs. Just don't do it. So we asked, okay, great. I know that you guys aren't able to do that, but I do know that you have a pretty tight supply chain and that you have a lot of this data already. Can you please do TM65 reports for me? And very luckily they did. We got them within 2 weeks. They are obviously unverified, but again, we wanted to get some amount of data so that we can understand going into the tender set what the impact is going to be stage A1 to A3. So like Max was talking about, to really know like the actual data about the supply of the luminaire, like where all the different components of the luminaires come from and what we can control moving forward. So I do have the information from both these people now. So if either of them are watching, you're all good. And then we have to review the data, right? So we we had a revised quote from DRK, right? So originally it was 2 25-watt fittings, and then they, in the background, went ahead and looked at exactly how they were going to design the new luminaire. And we went from 50 watts to 40 watts, which is great, except I was silly and I did our calculations at 25 watts each because I didn't actually take the losses from the whole system into consideration. So great on them for making a savings, because obviously higher efficiency and less wattage in general is great. But I had to redo our calculations. Luckily, it's fine. But these things do happen, right? When you have so much data and so many, again, different points of data that you need to compare against one another, it is easy to lose something in the process. And then again, reviewing the data and recalculating, right? So we had put kind of the luminaire on the top, so a 12 watt, 1250 lumen output fitting into our calcs. And then I later realized, oh, actually, wait, we have the same luminaire, slightly larger, in a 12 watt, but has a much higher output and a much better efficacy. Again, going back to what Max and Teresa were talking about, higher efficacy often means lower carbon footprint for that and so actually what ended up happening is that we saved 3 kilograms of CO2 for each iteration of this fitting because we went to the more efficient one. And this is just an accident, right? Like we had accidentally put in a lower efficacy fitting into a calc without knowing that a higher efficacy one was available. And the only difference is the diameter. So instead of a 48 millimeter diameter, we went to a 70, and it's completely fine. So sometimes there are easy wins. And again, those easy wins aren't necessarily carbon driven, but they do have a carbon savings. And then review the data, revise the data, present the data. It's all about making sure that things are correct. So getting the quantities right, getting your burn hours right, understanding what your avoided CO2 is. I mean, this we presented to the client. They were absolutely overjoyed. We will clearly need to do some analysis as the product design is happening, as the remanufacturing goes in. But I would be very happy to be here again, maybe in a year and a half's time when we're done with construction, and say, yes, we did it. This is what we saved. This is what didn't go to the skip. But it is a long process, and it is not particularly easy to request all of this data and make sense of it and implement it. But I would just encourage people to keep trying and keep requesting, and to think about all those small decisions that you make in your designs on the basis of, can this possibly have a carbon savings? Because that's what we've done. And I'm really excited about seeing the project go forward. And that's me. Thank you very much.
Thanks, Kael. And if I can invite all our speakers and panelists to join us.
I'm going to end the slideshow.
Nigel, EPDs, a tool in the toolbox. I don't know whether they're working in the real world yet, but what's your take on that?
I think it's been very good to hear, from 3 different perspectives, EPDs and the relevance of environmental information. Particularly, Kael very much sort of clear-eyed at the sharp end. What environmental data is necessary to make a project work? I mean, Teresa had a slide that showed the range of European legislation, the avalanche, the tsunami that is starting to impact European companies, but will trickle across to the UK as well, undoubtedly, which are increasingly putting pressure on having better environmental legislation, which does imply EPD. So I think there can be little doubt that it will be the sort of the de facto standard for environmental legislation in the future. I would just like to give a note of encouragement for some manufacturers looking at some of those timescales. I think in the first few one-off EPDs that Recolight have done, we've actually been able to, provided the data is available, actually get the process completed in about 3 or 4 months or so using the one-click LCA platform and EPD Hub. So with some turbocharging, it's possible to make it a little faster.
Okay, interesting, because it appeared to be losing out to TM65, didn't it, there on the timescale front?
TM65 on its own is undoubtedly going to be faster than an EPD, no doubt about that. Yeah.
Okay, we've got about half an hour to take some questions from and they're coming in thick and fast. And let's take the first one. It's from Nicholas Thulin, who's Sustainability Manager at Fagerhults. Can we trust third-party verification? Sometimes we see unrealistically low results, even for standard 600 by 600 flat panels. I'm guessing that means very flattering results. And Max, we're looking at you for this.
Was flattering results a pun there? Yeah, third-party verification is a conversation that always goes on within the EPD world. There's no question that third-party verification is necessary because you don't want to be verifying your own results because that leads to more questions. I understand where the question is coming from, and I think one thing I think needs to be appreciated is that when we're talking about third-party verification, we're talking about an independent person who understands life cycle assessment, and is making sure that the EPD follows the right standards, follows the right PCR rules for your program operator. That's the core of what their job is, to make sure that you're following the rules. When it comes to the data itself, so your bill of materials, your input energy, your utilities, a verifier only has so much capacity to actually check those numbers, and so it's far more reasonable for us to ask the verifier to say, is this reasonable? And the verifier should have a reasonable understanding of the product category, and they can say, yes, okay, you've got 5 kilograms of input material, and that equates to this much CO2. That seems reasonable. What they can't do is audit. They can't audit the whole process, and so there is an element of trust that's kind of put on the shoulders of the manufacturer. I believe that there are program operators that have mechanisms by which you can ask whether certain things are correct. I don't know the details of that. But we're right to question it. I think as an industry, we need to move forward at the same, together. But ultimately, third-party verification, to answer the question, yes, I think is important. We can't be verifying your own results.
But according to your graph, it's the program operator chooses the verifier, not the manufacturer who's submitting the product, correct?
Yeah. I mean, technically, yes. There's different ways that a manufacturer can go about it. I've got a friend who works kind of knee deep in EPDs, and she says that she suggests to a manufacturer, if you know a verifier that verifies these sorts of products and you trust, you can speak to them, say which program operators they work to verify through, and you can work it that way. So you can actually seek out a verifier. It wouldn't necessarily be a conflict of interest because the verifier still has to make sure that they're doing the right checklists. But yeah, you're right. The program operators will assign the verifier, and generally a verifier might work for 1 or 2 program operators, sometimes just one. That's kind of the nature of it anyway.
This is a related question, which it is for you again. I think Max initially is Chewy Pavel of sustainability engineer at Glamox. What are the best product category rules to select for your luminaire EPD base? Are there PCOs that should be avoided, and if so, why?
Oh, that's a good question.
That's it.
I don't know of any PCRs you need to avoid. I've not been exposed to any PCRs that I would personally recommend you avoid. As a general rule, lighting kind of falls within the building and construction kind of sector, and so we naturally fall into the PCR EN 15804 in Europe. So EN 15804, I think, if you're looking at an EPD for lighting, you should be able to find in the EPD this is created to the standard EN 15804. That's kind of like the main PCR that I think we should be working to. You then have more specific rules, and Lighting Europe has spoken a lot about this. You've got the PSR 14, PSR 0014, which is luminaire specific, and that is undoubtedly the most comprehensive set of product specific rules that I think the lighting industry should be paying attention to. And you can apply the assumptions and the rules and the basis of that PCR to your LCA. And I would encourage people to be doing that.
Oh, and we should, this difference between A1 and A2, we should be using the A2 version of, correct? Is that?
Yes. Yeah. To prevent confusion, I've spoken in my slides about the different life cycle stages, and you've got A1, A2, A3, A4. Those are life cycle stages, but you also have A1 and A2, which are 2 different amendments of the EN 15804 standard. So you've got A1 plus A1 and plus A2 are just updated. And so the A2 is the most recent. I can't remember when that was updated. I think maybe the last 5 years. But it's slightly different to the plus A1 standard. And so yeah, EN 15804 plus A2.
So use the latest standard
Yeah.
is the basic advice. Marcy Song, who's the director of the Independent Lighting Design Practice CM, is saying, varying across regions, what are designers' experiences when it comes to EPD requirements within your detailed design or technical design spec books? Kael, that's one for you, I think.
Yeah, I can't speak too much on this because we primarily do products in the UK.
Hmm.
But I think Sophie O'Rourke talked about this recently, where yes, it's a bit of a wild west, where you will have other countries kind of asking for, oh, can you figure out what the carbon data is for this? And then you go, okay, but like on what basis am I acquiring this? Like, what is it getting used for? I think in the absence of anyone asking for specific carbon data on a project, you can still make carbon conscious decisions. And I think that that's probably where I just encourage everyone to start with. So again, even if your client, it doesn't require you to have any sort of TM65, 66, or EPDs in your specifications, you can put it in anyways. Like it's completely fine. Or you can make your own product decisions in-house with those things in mind without ever letting the client know that it's part of your design process. Um, I think I likened it to like putting vegetables in your picky kid's dinner, right? It's like you know that you're doing a good thing for them. They don't need to know that you're doing it,
Yeah.
but it should be part of your process. As far as actually putting any language into your specification, I think that Leela and the Green Light Alliance had a guide kind of how to do this and spec language. I can try and dig that out as part of the resources to follow up with this presentation. But effectively, it's just putting a line item in and explaining, okay, I have EPD information. I'm including A1 to A3, and that's how I'm comparing things. Or I have, a benchmark for TM66, and everything needs to be above, a 2. I think there's quite a lot of firms. I know, like Nolte had a pilot project for that where they have like a minimum TM66 score that they have in their specs. I'm pretty sure that
Hmm.
Arup has something quite similar for
Hmm.
carbon footprint. So there are individual firms kind of setting their benchmarks and putting it into their paperwork. Obviously, it's hard to ask people that would be your competitors to know what their language is. But I think that the Green Light Alliance is trying to harmonize that and to give some kind of standard spec language. So I'll make sure that that's included in the packet that we send after.
Okay. It's what, I suspect a lot of people looking at those tables were thinking, well, where's the killer number? This is traditionally the like, we've traditionally done this. Where's the number I need to know? Which is the one? And it seems to me what you're saying is you shouldn't be looking for that killer number.
Yeah, I mean, so like Max pointed out, like that use phase is huge, right? And Teresa also made that very clear. Like the use phase is huge, but the use phase in an EPD is based on assumptions. So I would frankly say if you are going to be doing any sort of like power calculation or power density, like do that separate to an EPD. Don't look at that piece. Also because that varies wildly from country to country. Like that EPD is done on the assumption that it's coming from a specific country's grid, which the UK will be different from Sweden, will be different than like, the US. Actually, even the US by state is going to be wildly different.
Hmm.
So we as a practice don't tend to look at that piece. We tend to look at kind of the A1 to A3 because, as Max rightly pointed out, that is the most like specific data, not based on any assumptions. So I guess back to the short answer, or sorry, the long answer for a short question. You can put in the A1 to A3, right? And you can use that as a benchmark. You can say, I need a downlight that is going to be roughly around 10 kilograms of CO2. And you can say, okay, I can reasonably accept something that's 15 or 5, but like 30 might be a bit out of bounds, right? So again, it's understanding kind of that first part, the really specific data about the manufacturing process, the materials going into the luminaire. That I think is more comparable and more easy to understand, particularly when you're trying to speak to a contractor or a client. Um, so again, having the numbers is important to put in a spec, but the conversation about why the numbers are what they are, that's kind of a more important conversation to have with the client, regardless of region or project type.
Could I just chip in there and just add that as at least in the UK and probably sort of globally, as grids decarbonize, so actually the embodied carbon is going to become a bigger proportion. And actually, Teresa's graph that showed a sliver for embodied and a huge amount for in use, that sliver will increase as the carbon intensity of the grid declines over time.
On a windy day, it uses less, it doesn't have, has better numbers. Ian Legg of Signify is saying EPDs versus TM66. What's the difference for a user? And I suppose one of the simple ones is that it's a simpler, the TM66 is very visible too. Everybody knows the numbers, whereas the EPD is different in the sense that it's more complex. Kael,
A 66 or 65?
six is asking 66, but you could
Well, I mean,
discuss it.
so TM66 reports a totally different set of things. Right. So TM66 is about circularity, right? It's the CM report. And so I think, again, it's another thing, like we're getting data points, right? So someone also asked a question about like, how do you calculate the D stage in an EPD? It's a guess, right? It's a guess based on scenarios. It's a guess based on how you put the luminaires together. And like, I believe that a TM66 is a much better way of trying to talk about like the repairability of a luminaire and the end of life of a luminaire than the D stage in an EPD is. So I think you're probably looking in the wrong place for information about circularity. If you're looking to an EPD D stage, you should be looking at a TM66. And all these things fit together, right? So like a TM65 is kind of like an EPD light. I mean, if we really basically like break it down, that's what it is. And it can be third party verified, but doesn't cost as much money to do. But obviously, still, as Teresa was showing in her graphs, takes up all of that time for the data collection. And so again, TM65 or EPD or whatever it is just the sliver of the output. It's all the data collection in the first place that makes sense. So do them both. I think there's a lot of things you can't answer in one that you can't answer in the other, and vice versa. I don't think they compete with one another.
Bjorn Schmidt-Hart is asking, per Ledvance's slide on global warming potential, could you please explain the end of life indicator? What's it based on? Is it based on estimated quantities going to waste, scenario data versus actual data? Does end of life stage include reclamation of waste for recycling, or is this accounted for in the manufacturing stage?
This seemed to be a question for me. Okay.
I think it is.
Kael already has mentioned this for the end of life also somehow. She's mentioned D stage, but mainly it's the C. So we are using scenario data. We don't have a lot of primary data yet. Why? Mainly also to stick to a bit to comparability between EPDs. If we would really have real data, it would be quite hard. And the other aspect is, first we try to start with creating EPDs. Then second step, mainly streamlining it, learning. And then in the third step, we are able also to refine how we are calculating, mainly also for the transportation, for the distribution stages, to use also real logistics data. That's also can be found also in our EPDs written per stage. What are the assumptions for end of life? Currently, those are assumptions.
Mm-hmm.
Did I help?
Again, thanks, Teresa. I was going to chip in again and say, actually, at Recolight now, we are able to produce actual end of life data on a transaction by transaction basis. So for every collection of waste lamps or collection of waste fittings, our in-house system will produce an actual carbon estimate of the carbon emissions associated with the transport and treatment. In fact, Max has been involved in making sure that our systems calculate that with a reasonable level of accuracy. So we're able to generate some real world data, although clearly that's not yet feeding into EPDs.
Samuel Bogue, of a design engineer at Dialight, is asking, how can end users leverage product EPDs to report Scope 3 emissions and ultimately save money?
A complex question with not a simple answer. I'm not going to pretend to be familiar with the kind of the transition of EPD data into kind of Scope 3 data, but there's definitely a relationship there. If you think about your Scope 3, kind of the greenhouse gas protocol, kind of Scope 3 categories, EPD data can definitely fit into that. I think that's something that I'd have to kind of go into the details of the two of them to see where you can draw comparisons. And and suck data from one into another. I don't necessarily know of any specific kind of service offerings or solutions that can do that. It wouldn't surprise me if there are some outfits that make them bespoke. But at the end of the day, it's a relationship between your purchasing and what you're distributing, I guess, at the end of the day, and your in-house utilities, and you can relate that to your different scopes 1, 2, and 3. But I don't have a specific answer as to how you can. I don't know if there's any framework for being able to draw one kind of draw some data from one into another.
Ash K. Talware is asking, is it possible to have more than one program operator for one company for their different product lines, which are completely different in their nature? So company A having X program operator for food products and Y program operator for the industrial machinery products. I'm guessing the answer is yes.
Yeah, I can't see why not. You could, if you wanted to throw money at the situation, you could do an EPD with 2 different program operators and publish 2 different EPDs.
Yeah, I hope they be the same.
The same product, and hopefully it'll be the same. Yeah. No, I can't see any. There's nothing to stop any manufacturer from using 2 different program operators at all.
An anonymous delegate is saying it's also worthwhile to mention that EN 50693 IEC 63366 PCR for electrical and electronic devices, mandating the FU, the functional unit, and establishing the rules for product families. You're
Yes.
nodding, Max, yeah.
Yeah. So that's another. Yeah, it's a good point actually. It's a standard that I probably should have named and shamed, along with the EN 15804. So it's another EN standard that's for electrical goods. Importantly as well, it also mentions in that standard that you have to include the use phase if you want to comply with that standard, which makes sense for electrical goods, because the use phase, as we've mentioned multiple times already, is a real hotspot. And so that's not necessarily defined in EN 15804, because from the building perspective, there are going to be loads of building products that have the use phase is just sit and exist. Whereas for lighting, it's much more consume energy and use it to provide a function. So, yeah, good point, and thanks for mentioning it.
The aforementioned Hattie Emerson is asking, saying, Kael touched on the carbon benefits of refurbishing and remanufacturing luminaires, but it doesn't always make carbon or cost sense. Is data available which breaks down where the carbon is in the components of the product, such as the driver, the casing, etc., to help with that decision making? Good question.
I mean, you'd have to do that on a project by project, luminaire by luminaire basis.
Mhm.
But I think for the project that I was talking about, we did actually have a bunch of other luminaires we identified, and DRK came back to us saying it's not going to be worth your time or money. So they did an in-house analysis looking at the luminaire, looking at similar typologies, and kind of figuring with their product designers whether or not it's suitable for remanufacture. And some of them were too flimsy or just made of materials that were going to be difficult to alter, or kind of putting in a chip on board LED was going to be basically making a luminaire from new. So yes, like not every luminaire that we wanted to reuse, we could reuse because it was not designed to be remanufactured. So it's very important that we kind of spend the energy and effort in the places where luminaires are already designed to kind of have a kit of parts put back in them, and why we are stressing to luminaire manufacturers who are making things today to make them more replaceable, repairable, and more of a set of common parts, right? Without getting into the scary Zog is going to make everything exactly the same sort of territory, but just making things easy to disassemble and to repair. So yeah, unfortunately, we are going to have to recycle quite a significant number of luminaires kind of in some of the front of house spaces, but simply because just in the effort of taking them out of the ceiling, they're going to get compromised, or because it's just not suitable to put new kits in it. So yes, that has been done. So our remanufacturer did that exercise and kind of gave us back a kind of scale of repairability versus carbon. So people can do it. And I would encourage anyone that does kind of work in that remanufacturing sphere to just be honest about whether or not it's worth the time, money, effort, etc., on a case by case basis.
Joan Smith Hart is asking again a question about power factor regarding the CO2 calculations. And I think this is I think he's referring to Ledvance here. Regarding the CO2 calculations, was it only based on wattage instead of apparent power? Was the power factor differences between fluorescent and LED technologies taken into account?
Oh, I think that was a question about the sheet that I was showing.
Okay, so yeah, so power factor, you can have that one. Okay.
I don't think so. I don't think so, no. I think it was like a very basic calculation. It wasn't based on like losses and anything like that. So again, it was a very rough kind of push in the right direction to show, okay, it's this versus this. Like again, that was the manufacturer's first go at it. I'm sure that we'll get clearer data moving forward. But Teresa, you can also answer that if you fancy.
Yeah, if anyone, Max, you can come. Yeah, or Teresa, you power factor.
I'm also interested from time to time, or not especially for that, where the question comes from actually, because we had this internal discussion also quite some time ago. That's why I'm not remembering all the complete outcome. But in general, we are using the real power that is consumed, the actual energy built, and not yeah any apparent power. That's just not reflected in the EPD.
A question that I have really is actually is material passport. Are we going to see EPD sort of merge into material passports in the future, or should that happen? Or is it, are you basically banging together EPDs and TM66s into one super doc?
I mean, again, I think it's a project suitability thing, right? Like you were talking about the case study at the start of the call, about having material passports for everything going on in a building. So I think it's just being flexible, right? Knowing what your project needs, knowing what your client's outcome is meant to be, knowing what your like individual like desired outcome is as a lighting designer or an electrical engineer or a manufacturer. I think we're at a place where we're using very similar outputs to express a similar kind of desire and need and outcome for sustainability. So if someone said to me, "Hey, don't worry about getting EPDs or this, like we're using material passports for this project," I would go, "Great. How is that feeding into what else you're doing?" I think again, it's just like an asking, why are we doing this, and what is the ultimate goal? Like, what are we trying to achieve by doing this? And again, like I don't think there's one thing that's better or worse. It's just different ways of tackling kind of the same sustainability and circularity question.
Yeah, and having the information is what's important. The reason I ask is because material passports are coming down the road in the next decade, but probably we're going to see them. I'll just one final question from Bjorn Schmidt-Hart. With reference to the environmental impact stages as reference from EN 15804, which refers more to the construction sector, construction material and products, how effectively does EN 15804 relate to product production, like lamps sold to consumers, which are on not construction material? So how comparable is ISO 14040 and ISO 14044?
Right. Okay. So first of all, asking how useful EN 15804 is for lamps, luminaire products. Is that right?
How effectively does 15804 relate to product production, like lamps sold to consumers, which are not technically construction materials?
Yeah, I mean, I would argue that the same methodology and modularity still applies. I've mentioned that A1, that A2, A3 stages, your material extraction, transport to your manufacturing facility, and your manufacturer. Obviously, that's a part of what was a very large puzzle. I showed that huge table, and the first three stages all relate to that production stage. Given that these are products that are to be used in the built environment and to be used in buildings, that modularity I think still is relevant, and that is defined by EN 15804. So yes, I think it's a perfectly good standard to at least start with, and you can again marry that with the other standard that we mentioned that I can't remember the code of, but for electrical goods. You also mentioned ISO 14044.
Yeah, for 40,040 and 40,044.
Well, it's worth noting that those are standards that are a lot more that have a much broader scope, and they are much more to do with the life cycle analysis, how you perform a life cycle analysis. You can apply those standards for all sorts of different things. It can be a product, it can be a service, it can be a process, it can be a building. There's a lot of flexibility, and that's what LCA consultants will use for different types of products and projects. They're the framework for how to conduct an LCA. You then have to apply other standards, so your EN 15804, your ISO 14025 for EPDs. You have to then apply all of those in a jigsaw as to how you're going to do your LCA to make it relevant and comply with the standards for an EPD.
Okay, good. Well, we've come to at 12:30. We've answered all the questions. So good work, everybody. Thank you for your presentations today, Max, Kael, Nigel, and Teresa. Our next webinar is on Thursday, the 19th of March at 11 o'clock, and it is drilling into Cat A fit outs and how we can reduce waste and how we can, the alternative ways that we can do that. So it remains me to thank you all, and I'll see you at our next time.
And on behalf of Recolight, thank you very much to Ray for hosting, Kael, Max, and Teresa for presenting, and to our in-house webinar super maestro, Suzanne, as well. Thank you.
Indeed.
Bye-bye.
Thank you, sir.
Thank you.
Thank you.